16 is actually, yeah, this is the only one in this chapter that I think is actually hard. I genuinely think this is quite difficult. So well done on starting it, and extra well done if you get through it. So remember, L of x is x plus 1. That's literally just a straight line. Gradient 1, intercept 1. So it looks like this. So its range, like there's no limit on its range, all real y. If we then have q of x, well, that's x squared plus 2x, which is the same as x plus 2. If I were to draw that, it has intercepts at 0 and -2, and it's concave up. I'm not drawing it too well. It looks like that. So its range, well, I need to find this point where it turns around, don't I? That's going to be halfway between the x-intercepts, so x equals 1. So q of 1, -1 equals -1 plus 2. So -1 times +1 is going to be -1. So its range is y is greater than or equal to -1. Okay, for B, we have L of q of x. Now q of x was x squared plus 2, so we have L of x squared plus 2x. L was x plus 1, so what we have is x squared plus 2x, that's instead of x, plus 1. And if I wanted to factorise that, that would come out as x plus 1 all squared. I want to determine its range, so I'm going to sketch this thing. X plus 1 all squared, normal quadratics has been moved left 1. So it's going to look like that, so its range, you're never going to get something negative. For C, I'm doing q of L of x. Am I? Did I read that correctly? C, q of L of x. Q of L of x. Well, L of x was x plus 1, so I've got q of x plus 1. Q is x squared plus 2x, so I've got x plus 1 squared plus 2x plus 1, which gives me x squared plus 2x plus 1 plus 2x plus 1. So I've got x squared plus 4x plus 2, which is actually x plus 2 all squared. So if I were to draw this one, I always recommend drawing them if you're trying to find domain and range. -2, it's been moved left 2, if I can draw. So this one's range, again, y greater than or equal to 0. Okay, find the zeros of q of L of x. Well, I kind of already have zeros. X equals -2, and it's a repeated 0, which means it turns around there. Okay. So, L of 1 on x plus 1 is, well, L is x plus 1, isn't it? So I've got 1 on x plus 1 plus 1. Now, I want the lowest common denominator, so I've got 1 on x plus 1 times x plus 1, x plus 1. Don't forget 1 is the same as 1 over 1. So I've got 1 on x plus 1 plus x plus 1 on x plus 1 gives me, add the tops together, I get x plus 2, bottoms are the same, x plus 1. Q of L of 1 on x plus 1 is that squared plus 2 times that. So I've got x plus 2 over x plus 1 squared plus 2 x plus 2 over x plus 1. So I get x plus 2 squared over x plus 1 squared plus 2, I'm just going to put the 2 with top. To get the same thing on the bottom, I'm going to want to times this by x plus 1 over x plus 1 because I want x plus 1 squared on the bottom. So I've got x plus 2 squared is x squared plus 4x plus 4. Ooh, that means I stuffed up massively. 4x plus 2. Yeah, that's quite embarrassing. Just ignore whatever I did there. I'm going to quadratic formula this one. Y equals x squared plus 4x plus 2. X equals minus b minus 4 plus minus the square root of 4 squared, take 4 times 1 times 2 all over 2 times 1. So x equals minus 4 plus minus the square root of, well, this is 16, take 8 over 2. So I've got minus 4 plus minus, well, that's 8, which is the same as 2 root 2 over 2. So I've got minus 4 plus minus root 2. So if you were yelling at the computer then, I apologize. Minus 4 plus minus root 2. So we've got things like here. This point here would be minus 4. Which means I've got minus 4 squared plus 4 times minus 4 plus 2. So I've got 16, take 16 plus 2. Why is that? I don't know that question. What have I missed? X squared plus 2x plus 1. Oh, plus 2. Oh gosh, this is the worst. Which gives me plus 3. This is much, gosh. Which means that's x plus 3, x plus 1. Which means this is minus 3, minus 1, which means this is minus 2. What I'm doing is substituting minus 2, not minus 4. Minus 2 squared is 4, take 8 plus 2, negative 2. So the range, y greater than or equal to negative 2. Sorry about that. So our zeros, negative 3 and negative 1. Okay, back down to this one. X squared plus 4x plus 4 plus 2. Then I've got my x plus 2, and don't forget I times that by x plus 1. And on the bottom of this, I've got x plus 1 squared because that's on the same on both sides. Gives me x squared plus 4x plus 4 plus, now I'm going to expand these brackets. So that's x squared times by the 2 out the front, that's 2x squared. 2x plus 1x is 3x times 2 is 6x. 2 times 1 is 2 times 2 is 4. Then I've got x plus 1 squared. Gives me 3x squared plus 10x plus 8 on x plus 1 all squared. Is that what I wanted? Nope, now I've got to factorise that. So 3 times 8 equals 24. 24, 2 times things that multiply to give that add to give positive 10. 4 times 6. So that's 3x squared plus 4x plus 6x plus 8, doesn't matter which order I did those, it would become the same. X plus 1 squared, which means I've got x outside of 3x plus 4 plus 2 outside of 3x plus 4 all over x plus 1 squared gives me 3x plus 4 x plus 2 all over x plus 1 squared. Finally, which is what we wanted. Okay. Oh, I'm so embarrassed about question C. Yeah, it is what it is.